This video will show you how to evaluate classification model results when using ScikitLearn in Python. In this example, this is the HR data where we're trying to predict who stays and who leaves the company. After we partition the data, then we create the models and we fit the model. So here we're taking our training data and we're loading it into the model and fitting the model. So when we're done here, we've come up with this trained log reg model. Then we put in the validation data and we predict the outcome variables. So this is Y predicted. And you can see that that is an array here. It shows, I've shown you a few of the values here, so you can see that it is an array. And then we see a classification report. So here's the classification report. And let's look at the call to this classification report. What we're doing is we're saying take the Y actual, the Y predicted, and then we're giving it the target names. Here on the left, this is the non-positive, this is the non-class of interest, and this is the class of interest. We're mainly interested in people who left the company and trying to figure out why some people leave and when some people stay. And then out here we can determine how many digits are showing up in this report. Scrolling down, we also have the confusion matrix. And this confusion matrix is showing us how things turned out in terms of what we predicted versus what was the actuals here. So let's understand this and sort of put this together. So when we look at this confusion matrix right here, we have our predicted and we have our actuals. So here we predicted that all of these would stay, and these really did. So these are our true negatives and these are our false negatives. Here we predicted that both of these would leave, and these actually did and these did not. And so that's how to really kind of evaluate this. So let's go down and look at the results from this model right here. Okay, so how can we sort of like put this all together? All right, so what I've done is I've taken this information that is in this confusion matrix and I've done a little bit of calculation with it, and so you can sort of like see how what is in this classification matrix actually ties in to this classification report. All right, so basically what's happening here is we have these that are the true negatives and the true positives, and then we have the false positives and the false negatives. And you can see how these add up. So the actuals go left and right. So here, these are people that actually stayed. These are people that actually left. You can see the sum value, and so that's what support is. What support is adding these across this row and getting these values. So we know from this report how many in the data were actually staying and how many actually left. So that answers that right there. Now let's look at precision. What precision is it's a way of thinking about when we predict something, what proportion of the time are we right. So what we did is we predicted that 4,522 would stay, and we were right 47 of the time. So what proportion is when we were right out of the total? It's 98%. That's where that figure comes from right there. When we predicted someone stayed, 98% of them actually stayed. All right, and then over here, when we predicted that someone would leave, we were right 375 out of 1,478 times, or 93% of the time. So when we predict someone would leave the company, we were right 93% of the time. That's where this value comes from. Recall is what proportion of the population did you actually find in each relative class. So if you look right here in recall, what recall is saying, all right, of those that stayed, how many did we find? And so 4550 stayed, and we were able to find 4447 of them. So we were right 98% of the time. That's where that value comes from. Of those that left, which was our main classification of interest, we were right 1,375 times out of the 1,450. In other words, we found 1,375 out of 1,450, or we found 95% of those that actually left the company. So that's where that figure comes from. Now later on in the semester, we'll learn how to calculate the F-score, which is a type of an average across precision and recall. So we'll look at that a little bit later. But I just wanted you to see how the values that are in this classification report actually are related to what's in the confusion matrix. And so you can sort of like start getting a better sense of what these figures actually mean. I've also calculated the base rate, which is the proportion of our records that contain the class of interest. In this case, 1,450 left out of 6,000, so our base rate is 24.17%. Now let's look at the way that we save this information and pass it around into this pretty matrix that actually does this classification or confusion matrix for us. So when we had this confusion matrix right here, there's a method right here called the confusion matrix where we passed in the y actual and the y predicted. We saved it over here into a little array. This is a NumPy n-dimensional array. And then down here I say, let's see what's in there. Well, what's in there are the cells that are in the confusion matrix. So all it really did was save the 4 different values of what's in the confusion matrix. Then we take that little data structure, that little 2 by 2, and we pass it in to the plot confusion matrix function. So there's that. We put in the classes that stayed and left. So there's our negatives and there's our positives. Again, the classification of interest is considered to be positives. And the classification that is not the main class of interest is not considered positive. And then once that's done, once those are passed in, then it can make this nice, pretty confusion matrix. You'll notice that this and this and this and this are the same. This just does a nice job of helping you remember what the true is and what the predicted values actually are.